In this video, we're going to take a look at the graph of a function and we're going to determine its slope. Now remember, mathematically, we define the steepness or the slope of a line as the ratio of its vertical change, which is rise, to the corresponding horizontal change, which is run. Now again, slope just represents the rate of change of y with respect to x. Now if you take a look at your given function here, we can see that our function is in the form of y equals mx plus b. And we know that's a linear function. So I want you to pause the video now and try to graph this function and also determine its slope. So as previously stated, the function here is in the form y equals mx plus b, or fx equals mx plus b. And we know that that's a linear function, so we can just simply graph the function by connecting 2 points on the graph with a straight line. Now we can calculate 2 ordered pairs. We can then plot the points, graph the function, and determine the slope. So for example, if you were to just pick any value of x, so let's say at x equal to 3, what would your value of y be? Well, you would just simply plug in the value of 3 into your function. So we would have negative 2/3 times 3 plus 1, which just simply works out to negative 2 plus 1, which equals negative 1. So that gives us a point of x being 3, y equaling negative 1. Now let's take a look at another point. So let's just say at x equal to 9. Now you could pick any value for x that you like. I'm just randomly choosing a point. So when x is 9, what would y equal? Well, that's easy. You just simply plug it into your function. So negative 2/3 times 9 plus 1. Now this works out to negative 6 plus 1, which equals negative 5. So now when x is equal to 9, y is equal to negative 5. So we have 2 points already. All we would have to do is plot those 2 points and connect them because we know our function here is in the form of a linear function. Now another thing to point out is that since we already know that this function is in the form of a linear function, then we also know that the negative 2/3 represents our slope here, and the positive 1 represents our y-intercept here. So we know that the graph of our function should have a negative slope of 2/3, which means it's going to be a decreasing function, and we already know that our y-intercept is when x is 0, y is equal to 1. So using all that information, let's plot our function. Well, let's quickly write down what we know. We know 1 point when x is equal to 3, y is equal to negative 1. We know another point when x is equal to 9, y is equal to negative 5. We have our y-intercept, which just simply means when x is equal to 0, y is equal to 1. And we also know the slope of the function is equal to negative 2/3, which is just simply telling us the steepness of the line and that it's a decreasing function. So let's go ahead and plot this on the axes below. When x is equal to 3, y is equal to negative 1. When x is equal to 9, y is equal to negative 5. And we also know that we have a y-intercept here. When x is equal to 0, y is equal to 1. So if we just go ahead and connect all 3 points there, that would be the graph of our function. So let's just verify that the slope here is indeed equal to negative 2/3. Now again, we knew the slope was equal to negative 2/3 because our function followed the form of a line, where the equation of a line is equal to mx plus b, where m represents slope. So here, negative 2/3 must be our slope. Well, let's just verify that with the 2 points that we found by plugging in some random values of x. So here we have 2 points, and remember that slope is equivalent to rise over run, where rise is just simply the change in y over run, where run is just simply the change in x. The change in y is y2 minus y1, and the change in x is x2 minus x1. Now our 2 points here that we figured out by plugging in random values of x were here when x is 3, y is equal to -1, and here when x was 9, y was equal to -5. So our rise would just simply be -5 minus -1, and our run would just simply be 9 minus 3. And this works out to -4 divided by 6, which then reduces to -2/3.